Okay, so chapter 4, we're going to get more into mean and median and center and spread of data sets. So today we're just going to look at the center of a data set. So we sort of talked about in chapter 3 with center, I just said you could use mean or the median. Like I said, we're going to get more in depth on these today. And I also am going to show you how to do it in the calculator. So there are two most common measures of center are obviously the mean and the median. So we call the population mean, this like U looking thing, this is actually the Greek letter mu. So it's the average of all the values in the entire population. Second semester we're really going to focus on the difference between mu and maybe what you've seen before with X bar. Right now it doesn't really matter. So the population mean again is mu. However, since we rarely study the entire population, we use the sample mean. So the sample mean is the average of all the values in a sample from that population. And we use the symbol X bar to denote the sample mean. So here's the formula. X bar is all the x's added together divided by n, or the sum of all the x's divided by n. So suppose the average height of the entire class is 66 inches, so mu would be 66. If we were to randomly select 5 students and find their average height, we may find an X bar of 65.4 or 67.2. This is called sampling variability. We're going to get into sampling variability as we go on. But just know, the samples can vary from sample to sample depending on who you pick. You could pick all boys and have a high class average. You could pick all girls and have a low class average. So that's why our sampling techniques from chapter 2 kind of come into play. Again, it's convention of statistics to use Greek letters to denote population characteristics. We call those parameters. Then the values we use to estimate the parameters are called the statistics. So the book, for some reason, uses pi to denote a population parameter. They say because it's a Greek letter, we're allowed to use it. I don't really like it. We won't use it, but the book does. Again, the mean is also the balancing point of a distribution if you have a histogram. So you've seen those before. The other one that we talked about is the median. The median is the middle score. To find the value of the middle score, put the data in order and then do n plus 1 divided by 2, and that will tell you the position of your median. So, now if you have an even number in your data value, it's 5.5, so the averages between the 5th and the 6th scores would be the median. So if your 5th score was a 30 and your 6th score was a 32, the median there would be 31. So the median's not always a number in the distribution. And then the last one you may have heard of is the mode. It is the most frequent observation, although we very rarely use the mode. It can tell us some stuff about the information about a data set, but we very rarely ever use it. So what I'm going to do, here's my data set. I'm going to find the mean and the median. Now you can go through and add them all up, divide by whatever. There are 3, 6, 7, 8. I'm going to show you how to do it in the calculator. So if you have a graphing calculator, what you're going to do is you're going to go to Stat. You're going to go to Edit. Now I have data in here in list 1 that I want to keep for later in the notes. So I'm going to go over to list 2. I'm going to put 12, 20, 19, 8, 17, 23, 255, and 12. So once you go to Stat, go to Edit. I'm putting these in list 2 because I don't want to delete this list. So now I'm going to go to the Stat button again, and I'm going to go over to Calc, and I'm going to go to 1 var Stat. So Stat, Calc. This first one is called one variable statistics. So it tells you, if you have one variable, it tells you all the statistics. So if I press Enter, now again, mine's in list 2. If you have an 83 or a calculator that doesn't have the new operating system, it'll default to list 1. So if you want list 2, you have to hit number 2. If you would like your calculator updated, you can see me, I can update it. It takes like 5 minutes. So hit calculate. There's our mean right there. So the mean here is 45.75. Now the median, so it gives you a bunch of other stuff. It gives you the sum of all the numbers, the sum of all the numbers squared. We'll get to S and sigma later. Gives you the amount, and then it also gives you the min, Q1. We'll get to all this later. But again, the median here is 18. So you don't necessarily have to do it by hand as long as you have your calculator. And every quiz and test in here is open is calculator, so you're allowed to use your calculator on everything. Now, what happens if it turns out that 255 was recorded incorrectly and should have really just been 25? What effect will this have? Well, if you think about it, in terms of the numbers, the one number is really going to decrease, right? The mean is going to decrease, but the median stays the same. Maybe the median might move over 1 depending on where 25 falls, but it's still in the upper part, so I think we're okay. So we call the median a resistant, can't spell today, resistant measure. So a resistant measure is a measure that's not affected by outliers. So the median is resistant, but the mean is not, since the outlier of 255 has no effect on the median, but a big effect on the mean. The median is often used to describe the center of a skewed distribution, such as home prices. In a non-symmetrical distributions, the mean does not do a good job describing a typical value since it's heavily influenced by the extreme values. So, if we think about our skewed distributions, so if I'm looking at skewed left, so again, you have a couple numbers on the low end, most of the numbers are on the high end. The median is usually in the middle where the big bulk of things are. But what happens is the mean gets pulled down by these lower values. So your mean is here. So here the mean will be less than your median. Okay, because mean gets pulled left by the lower numbers. Which is why we kind of call it skewed left, because your mean's being pushed left. If it was like a symmetric, right, what should happen is if you're symmetric, your mean and your median should be the same. So now we're looking at, okay, what happens when it changes? So if I'm skewed right, what's going to happen is, again, the median's going to stay towards the middle, but the mean's going to get pulled up. So here your mean is going to be greater than your median. The mean gets pulled right by the higher numbers. So a good one to talk about here, this is like where housing prices come in. So like most houses, like neighborhoods, you have like a bunch of houses that are all around the same value, and then you have like that $1 million house, like that just pushes everything up. So you'll see a lot of times, like when you get older and you start looking for houses, they'll say the median house price versus the mean, because the median's a little bit more accurate about what you're going to pay. Same thing with like, now test scores would be the opposite. Same thing with test scores. Test scores would probably skew left. You have a bunch of people who hopefully did well and then a couple who did bad. Well, if I say the mean gets pulled down. I had one year where I had a couple kids who second semester just didn't try. They just didn't need the class and they didn't try. So their test averages were always like zeros or 10%. So I would take them out and report the mean or the median, because I didn't want them to affect what the class average was. When data is grouped into classes, what we'll sometimes use is we'll use the relative frequency of each class to estimate the mean. You're also going to see, later we'll talk about proportions, so the population proportion. We're going to use P. Again, this is where the pi is used in the book. And then our sample proportion, you'll see we'll use P hat, and the book uses P. But we'll really get into that later. But sometimes you don't look at the average, like the average height or the average weight. We're looking at the proportion of people who said yes. So there's the population proportion and the sample proportion. So another way to describe center is we use a trimmed mean. So a trimmed mean is a resistant measure that tries to avoid the influence of outliers by eliminating values in the low and the high end of the distribution. So if I want to find a 10% trimmed mean when n is 50, I put everything in order, and the lowest 5 and the highest 5 will be eliminated. So 10% from the top and the bottom. So it's really you're taking out 20%, but we say it's 10% because it's top and bottom. So find the sample mean and the 10% trim mean of the data below. So this was the data I had in my calculator earlier because there are n here is 30, and I didn't want to waste time putting in all 30 numbers on the video. So if I went through, I'm going to go to stats again, calc. Now I'm going to do list 1 because I have all these weights in list 1. So my average here was 146.37 pounds. These were the weights of the male weights, I think, from a couple days ago. Now we're going to do a 10% trimmed mean because we do have an outlier. At least we think we do. So if n is 30, I'm going to take out the top 3 numbers and the bottom 3 numbers. So I'm going to take out 97, 102, 105, and I'm going to take out 191, 195, and 225. So I'm going to go into my calculator, and in my list 1, I'm just going to delete those 6 numbers. So 97, 102, 105, 191, 195, 225. So now, what should happen, what do you think is going to happen to the mean? Well, we took out the outliers, so it's probably going to be closer to the middle. So now, our trimmed mean, there's no symbol for a trimmed mean, we just say trimmed mean, is 144.83. So notice what's happening. What happens is the trimming percentage gets closer and closer to 50. If I keep taking off numbers from the top and the bottom, I'm going to end up at the middle. So the trimmed mean gets closer to the median. So you get closer and closer to the median. So a lot of the stuff you already know. I would say trim mean might be the only new concept today, and just knowing how to use the calculator.